Now the supervised learning is over, and now we'll move on to the unsupervised learning algorithms. So first of all, what exactly is unsupervised learning and what's the difference between supervised and unsupervised learning? Unlike supervised learning, unsupervised learning has unlabeled data. That is, the data is not already labeled. We have input data only, and there is no corresponding output variables, just like in the supervised learning, right? There is no we do not have to predict anything in unsupervised learning, because the main criteria of unsupervised is to classify the things according to their behavior or according to their characteristics. There is no correct answer in unsupervised learning, and there is no teacher. There is no one to train the model, because we're not predicting anything, right? And algorithms are left to their own to find the hidden information in whatever data they have been given. For example, a child might not able to distinguish between a cat and a dog if he doesn't know what a dog and a cat looks like, but based on what he sees, he can differentiate between the two. Based on their size, dogs are usually large and cats are usually small in size, and dogs have wiggly ears, cats have pointy ears, uh, dogs might have a small tail, right? Cats generally have a long tail. So these are some kind of features that a child might recognize it. So in the same way, the unsupervised model also recognize these characteristics in the same way. Now we have two categories in unsupervised unsupervised learning. First is clustering. So what clustering does is it tries to find a pattern in the data set, because the data is an uncategorized data, right? So it tries to find the similar characteristics and it tries to form groups with similar behavior. So that is what clustering is. Association, on the other hand, is mainly based on the user's buying prediction or users buying pattern. And association discover rules that what a customer is buying and can suggest what they should buy together with, right? So for example, people that buy a new home, they are most likely to buy furniture also. So this is what association tells you about. Now, why do you need unsupervised learning, right? First of all, it can find all kinds of unknown patterns in the data which a human might not be able to find. It can find features which can be useful for categorization, and because it takes place in real time, so all the input data need not to be analyzed by humans, but it can be labeled by the machine itself, and it's easier to get the unlabeled data from a computer than labeled data. And there are several applications of unsupervised learning. For example, visual recognition, human behavior, house cleaning robots, right? And NASA uses it because they want to categorize newly found space bodies into different categories, right? And you can classify players in a cricket match. It is used for spam filtering. It is used for classifying network traffic, and it is also used for identifying fraudulent activities. The banks use it. So these kind of stuff. I'll give you a real small example. So let's think of an Airtel connection, right? If Airtel wants to launch its new connection in the market or in a particular area, first of all, they'll collect requests from different areas, right? They'll print the banners, they'll show the ads, and they'll collect the requests from different areas using clustering algorithm, which tells Airtel that from which area the request was more for connection, right? So Airtel will try to give the connection to that area from where the request was more, because in order to gain profit, right, as there are more number of customers in that area who are asking for the connection. The Arogya Setu app is another example of classification. Arogya Setu app, for those who don't know, is an application launched by the Indian government during 2020 pandemic situation. Using a phone's Bluetooth and location data, Arogya Setu lets users know if they have been near a person with the virus by scanning a database of known cases of infection. And this information is then shared with the government, and the government is able to classify different areas in red, orange, green, or even containment zones. Now we'll move on to the clustering part. In this lecture, I'll tell you about the k-means clustering. So as you all know that clustering means to cluster the different objects together with a similar behavior. So that is what k-means clustering helps us in doing that, right? So what it does is these are the three different random data points before k-means, and after applying the k-means, we'll come up with three different clusters. So that is the job of k-means, providing you with different clusters with same set of behavior in each cluster. So how it does it? So these are the steps we'll follow, or the k-means follow, to build clusters. So first of all, we'll choose the number of clusters. It can be 2, it can be 3, depending on your choice, right? But it cannot be more than the data points, the number of data points, because if you have 10 data points, the number of clusters cannot be more than 10, right? So let's say that we have chosen the number of clusters to be 2, right? We want 2 clusters out of these data points. So first of all, we'll choose the number we have selected, that is 2, and the next step is to select 2 different points within the data points so that they can be the centroids. Here the centroid means the center of the cluster. So whatever data points we'll select at random, it will become the centroid of the cluster. Because we have chosen the number of clusters to be 2, that is why we are selecting 2 points. If we have chosen the number of clusters to be 3 or 4, then the number of random data points to be drawn on the graph would be 3 or 4. So first of all, we'll select the 2 data points. So these are the 2 data points randomly, anywhere. Now step 3 is to assign each data point to the closest centroid. So from that forms the k clusters. So every data point will calculate the distance between every data point to these both centroids, and whichever data point is closer to the centroid, we'll color them according to that cluster, right? So this is an imaginary line just for showing that this is the center it passes through, right? This is the center between the two centroids, and as you can see that this data point is closer to this centroid rather than this centroid, and this data point is closer to this centroid rather than this centroid. So coloring all the centroids, right? So we have assigned every data point to the closest centroid. Now next step is to compute and place the new centroid of each cluster. So as you can see in this part in the blue region, this data point or this centroid is very near to this data point and very far from this data point. So we'll move the centroid to a particular location where the data point is almost the same, right, within the centroid or within the cluster, right? So we have moved both of these centroids in their correct places. Now the step 5 is to reassign each data point to the new closest centroid. So again we'll follow the step. We'll draw a line that represents the center between the two centroids, and we'll assign or reassign each data point to the new closest center. So now this data point has come closer to this centroid rather than this centroid, and this data point has come closer to this centroid rather than this centroid. So we'll reassign both of these data points. right? And if any reassignment took place, go to step 4. So now we'll go to step 4 and we'll compute again the new centroid. So this is the new centroid. These are the new centroids, and we'll reassign each data point again. So we'll find the closest, we'll find the center, and we'll reassign together. So this data point belongs to the centroid, right? So reassignment took place. Then we'll again go to step 4, do the same thing, and then we'll try to reassign the data points. So if no reassignment is possible, then the model is ready. So these are the two clusters that have been created with the help of k-means. Now, how to choose the right number of clusters, right? In the previous example, as you have seen, we have taken 2 clusters. You could have taken 5 clusters. You could have taken 7 clusters, right? So how would you choose the right number of clusters? For that, there is a formula called WCSS, which means within cluster sum of squares. So for example, if you can, if you have chosen 3 clusters, how would WCSS be calculated is, inside a centroid, we'll calculate the distance between each data point and the centroid, right? Between all the data points and the centroid, and then we'll square it. And then we'll do the same thing in this centroid and in this centroid also, and then we'll add them together, and this will give us the WCSS, right? In this case, this is the formula. If you have, and you could also choose one big cluster, right? It will have this distance from every data point to the centroid, and you could also choose the clusters to be 2, so it would have this data point. This way we can have as many clusters as data points. As I said earlier, in the case if you have 10 data points, so you can have 10 clusters, but that would make each data point for each centroid, right? So each data point will be inside the centroid, and in that case WCSS would be 0. So lesser the value of WCSS but not 0, the higher the cluster and the better the goodness of fit will be. And so we need to find the optimal number of clusters. And how do we do that? We do that with the help of the elbow method. This is called the elbow method. So let's imagine that initially you have chosen one cluster and you've calculated the WCSS. It was around 8,000. And then you have chosen 2 clusters and you've calculated WCSS, that was 3,000. And for 3 clusters, the WCSS came to be 1,000. And when you've chosen 4 clusters, the WCSS came to be around 900, right? So as you can see, going from 1 to 2 has decreased the WCSS drastically from 8,000 to 2,000, to 3,000. And then going from 2 to 3, the number was reduced to 1,000. But going from 3 to 4, the number was not drastically reduced. It was a little bit of change between 3 and 4. So it went down from 1,000 to 900. We are looking for this last drastic change, where the last drastic change has happened. So but going going from 3 to 4, there was no drastic change. So this would become the optimal number of clusters, right? So in this case, 3 would be the optimal choice. And because this graph looks like the elbow, so that is why the method has been named as the elbow method. Now, what are different pros and cons of this algorithm? Pros is it works well on small or large data sets, and it is very fast and efficient. But the only con it has is we need to choose a number of clusters manually. Now, moving on to the case study. So we have a shopping mall that wants to increase their profit by selling products to the customers, and they have the data already available of the regular customers which come to the shopping mall, and the following the data set which they have is their age, the customer's age, their income, and their spending score. Spending score has been given by the shopping mall to the customers who spends more or less. So spending score of a high spending score means that the customer spends more in the shopping mall, and a low spending score means that the customer spends less in the shopping mall. And it is based on their spending score every month, right? So that is why they need our help, so that we can cluster the customers together, and the shopping mall would make profit from those kind of customers who have more spending score. So let's move on to code and see how it performs. So this is the code of naive Bayes classification. First we'll look at the database. So the database has a customer ID, a gender, age, annual income in thousands, and spending score of the customers. Spending score is given by the shopping mall to the customers based on their spending. So we need to cluster the different customers together so that the shopping mall can target a specific customer and have the profit. So starting with 3 regular libraries, importing them, and then importing the data set. The name of the data set is mallcustomers.csv, storing in a data set variable, and then we'll only store the fourth and the fifth column, because we need only the annual income of the customer and the spending score. The customer ID, gender, and age is not required. So storing only those 2 columns in the X variable, and then we'll import the k-means method from sklearn.cluster library. Now I'm creating a WCSS list so we can calculate the within cluster sum of squares of every cluster, right? Because we need to select the number of clusters first. So in this case I am running a loop from 1 to 10 clusters, and because I need to select the optimal number of clusters, so I need to run a loop. And this n clusters would this is a parameter of k-means method. So by default, if you don't mention the n clusters parameter, it will take 8 clusters, but in this case, because we are selecting the number of clusters, so n clusters is I, and random state 0 means that the data will be selected randomly from the data set, and then we'll fit the method to this data set, and then we'll append it finally to the list. Inertia is the name for WCSS in the sklearn library. And this is the visualization part, where you'll see the elbow method, and you'll see the picture of the elbow, and you can see that the optimal number of clusters. So running this whole, so this is the graph of the elbow method, where you can see that the number of optimal clusters is 5 because of the elbow method, right? So now we know that the number of optimal clusters is 5. Now we can run the k-means method again and change the I to 5, and then this is the method where we build the dependent variable with values of clusters from 1 to 5. So 1 represents the cluster 1, 2 represents the cluster 2, 3 represents the cluster 3, and so on, right? So these different clusters are different groups of customers. So there will be 5 clusters, that means there will be 5 groups of customers. And now the visualization part. So we'll use the scatter plot, and with the help of, because scatter plot needs 2 variables, x-axis and a y-axis. So this first line is for the x-axis and this second is for the y-axis. So this x here, the capital X you see, is the name of the variable first of all, and this 0, the 0 after the comma, indicates the first column we are taking, that is the age column we are taking, right? So I'll show you the data set. So this 0 after the comma represents the annual income column, and this y k means Okay, let me show you what exactly y k-means is. So I'll print so as you can see that this is the y k-means. So here 3 represents the number fourth, 3 so here 3 represents the fourth cluster, 1 represents the second cluster because it starts from 0, right? And here 0 represents the first cluster. So here 3 means that the first customer will belong to the fourth cluster. 1 means that the second customer will belong to the second cluster. 3 again means that third customer will belong to the fourth cluster, and so on, right? So these are the k-means. So first of all I'm selecting the first cluster and the annual income, and in the y-axis I'm selecting the first cluster and the spending score. S here represents the size of every cluster. C means color, the red, and we have to give each cluster the label, that is label 1. And in that case, and the second one is for the second cluster. Here you can see that y k-means is 1, so it represents the second cluster, and this y k-means 1 is second cluster for the second column, and the color is blue, the label is different. And in the same sense we can have these 5 different clusters. So now for the centroid part, so this is the scatter plot for the centroid, for creation of centroid. So cluster center is the method part. K-means, from the k-means, k-means is the variable, is the object of the method. So k-means dot cluster center creates the centroid and will create the centroid using all the rows and the first index. And then this is for the x-axis, and for the y-axis we'll select all the rows and the second axis, and the size would be a little bigger than the regular clusters. Color is yellow and the label is centroid. So once I run it, and these are the title, and it's a label and y label and legend. So this is the graph, and as you can see that the red one is for cluster 1, the blue is for cluster 2, this is third cluster, fourth and fifth cluster, and these yellow dots are the centroids of every cluster. So you can see that this blue cluster, the fourth cluster, has very little income and a very less spending score, and this cluster has a very less income but they spend more than the first cluster. This cluster, the pink one, has more income but they spend less, and this green cluster contains all the customers with highest number of spending score, that is they earn more and they spend also more. So the shopping mall can target these specific group of customers, and this last one is in the middle ground. So they earn not more and not less, but they spend also not more and not less. It depends on the shopping mall that they want to focus on which cluster, but if the shopping mall wants to gain profit, they have to consider this cluster, or they have to concentrate over these customers. So this was a little demo of k-means clustering and how you can use the k-means clustering to perform clusters to categorize different situations. So that's it for this tutorial, and I'll see you next time. Thank you.